So this section is an extension of how we solved and tried to find where things touch, and an extension of inequalities that we did the last week. There's already stuff filled in because this is the third time I'm making this video because something's going on with my computer. So cross your fingers it works this time. So there's the pink graphed. There's the blue graphed. How do I know this is the pink? The last number is the y-intercept, and if you look, it crosses at -3. The last number is +3, and it crosses right there at +3. They wanted to know where are they equal. That means where do they intersect? They intersect at -3, 0, and they intersect at 2, 15. How many solutions did I get? I got 2. Great. But now what they're going to say is, okay, instead of it being equal to each other, they're going to be less than or equal to. So let's do an example. If I had x equals 3, you would go 0, 3, and x equals 3. How many solutions did you get? 1. But if I have x is greater than or equal to 3, then it's everything over here. Now I kind of have a lot because it's any number bigger than 3. So what I did, pretend you're not seeing that, is I went over to Desmos and I did just that. I graphed it, okay? So I want you to look. Here's the first equation, the second equation. Now I took this and I put that. Look at that, it turned green. And look at this, it's green from -3 all the way to 2. So I expressed that answer as -3 is less than or equal to x, which is less than or equal to 2. It is between -3 and 2. How many answers did I get? I got a bunch of them. What if this time instead of less than or equal to, and then here's me graphing it. Remember, if it's less than or equal to, it's closed circle, and this is an and, it's in the middle. What if this time, instead of less than or equal to, I said greater than? Well, let's look over here at Desmos, and I'm going to change this to greater than. What do you think's going to happen? Oh, I got too much happening here. Hold on. Now, instead of shading in the middle, it's shading this way or this way. So let's go back. And let's see. So this time it's going this way or this way. How would I express that answer? X is greater than 2 or x is less than -3. How many solutions did I get? I still got a bunch. Okay? So now we're going to go back to what we know. We know how to solve this. The first thing you do is you add 2. Let me make that a little bit bigger. I cannot split absolute value until I'm done with just having bars. Divide by 2. Now I split it. I don't really have space, so I'm going to split it over here and over here. This would be x plus 1 is greater than 2. And this would be x plus 1 is less than -2. Let me move that over. Subtract 1. Subtract 1. And then I graph it. I don't know if it's an and or an or yet. Greater than 1 to the right. Less than -3 to the left. So this is x is greater than 1 or x is less than -3. Okay? So they want to know how many boundary points are there. Well, let's look. Boundary means like where it ends. There's 1, 2. What are they? They are -3 and 1. Should they be filled or unfilled? Mark them. What portions of the number line contain the solutions, the left side and the right side? How many regions did you need to test? Okay, so now you're going, well, wait, what? This is a little bit different, so I'm going to highlight this in yellow. All right, it got messed up again. It's just going to keep happening throughout these videos, so hopefully it doesn't happen too much. But how many regions do you need to test? There'd be 3. The left region, this region, and this region. And hopefully this region works, and this region works, but this region doesn't work, and that means you did it correctly, okay? All right, let's turn the page. Let's try this problem, okay? So let me graph it on Desmos. So I graphed it on Desmos, and you'll notice, I put that in there already, that it's in the middle again, but it's dashed, it's dotted, so hold on. So I know my answer is between 3 and -2, and it was in the middle. So how am I going to show that algebraically? Okay, well, how would I solve this thing? I'd take all of this and move it over, and I'd end up with x squared plus x minus 6 is less than 0. Two numbers that multiply, two numbers that add. If I set it equal to 0, I'd get negative 3 and 2. Hold on, I think I made a mistake. So I made a mistake because if I set this equal to 0, that's negative 3. And if I set this equal to 0, it's 2. Now you have to decide, is it going to be an and or an or? Well, we saw that I think it was an and. Okay. Now, if I was to do this, I want to kind of transfer this over a little bit to make a little bit of sense. And I want you to see this. What if I did this? X squared minus x minus 6 is, instead of less than 0, I said less than y. Okay? And instead of putting the y on the right, I'm going to change it to the left. So everything is backwards. If I graph this, and I had this parabola, we know it's going up, and it would be dashed, right? And if its y is greater than, I'd be shading up. And if you look, if this is considered the x-axis, if I went through the x-axis, look at that. It's colored in the center. Now, what do I mean by that? It means that I'd be going in the center, so that's negative 3 is less than or equal to x, which is less than or equal to 2. And let's not make it equal to. I'm just very flustered. This video is driving me bonkers. Okay? Now, 3-70 is saying, okay, I want you to approach this another way. What if I had, instead of this, I wrote 4 absolute value of x plus 1 minus 2 is greater than y, so I'm going to pretend that's a y. And now I'm going to take this and go y is greater than 6. Let me move this around, so that's y is less than 4 absolute value of x plus 1 minus 2. Okay, what if I asked you to graph this? So if I graph this, let's say this is up 6, and then shading down. Okay, if I asked you to graph this, the vertex is negative 1, negative 2. Okay. Negative 1, this is kind of fake, okay? And then it's dashed. And I'm saying, okay, well now this time, this is getting graphed here. And if you go, hey, here's the x-axis. If you look, the point of intersection is out here. The point of intersection is out here. So if you see, like you did on the previous page, this was an or, it's the same thing. So that's how you get the same answer, because there's points of intersection, and it was x is greater than 1, or x is less than negative 3, greater than 1, negative 3, or. Okay? So I know that kind of seems a little confusing, but I think this will tie it together. So all of these have the same parabola. There's this one, this one, this one, this one. The same line. That one, dashed, dashed, whatever, it doesn't matter. We'll just make it solid, okay? And they want to know, how would you write the answer? Okay, so let me zoom in a little bit. If they say equals, so if you look, it's literally this is what it is. This is what it is. So we'll say that's the point 4, 0. And what is that? Negative, we're going to say it's negative 2, 3. I could be off, okay? But let's be consistently off. How many solutions did I get? I got 2 solutions. What are they? This is them. Now this one isn't going to be an equals, it would be an inequality because there's shading. So that means these are the right answers. So how does that work for the x-axis? If you look at the x-axis, it shades from here to here and then in between. So in a sense, my answer this time is going to be from negative 2 to 4 and in the middle. This is an and. So if I was to graph this, I would show that it's an and. How many solutions are there? There are many solutions. Okay? What if I had this one over here? It looks kind of similar, but this time it looks like it's shading from here over and from here over. So that's at 4 and everything bigger. And this is at -2 and everything smaller. So this would be an OR. If I was to graph this, open circle, and I should have made these less than or just less than. Who cares about open or closed right now? Right now we just want to get how we could graph both of these separately, find where they shade, and then write it as a one variable inequality. What about this one here? It looks like it's shading here. So that means it's from here to here. Well, that means everything in the middle, 0, 4, x, less. How would I show that? 0, 4. And I should be doing open circles, but it's fine. You get the idea. Okay? This is a pretty hard concept, okay? So, how does that apply to your homework? This is just same old solve for x. So solve for x. This one I'm actually going to do for you, okay? So, first thing you do is you set it equal to 0. Now I'm going to factor it. Let's remember how to factor. Two numbers that multiply to get -24 and add to get -5 are -8 and 3. Take that 2x minus 8, 2x plus 3. So let's remind you, the -8 and the 3, the -8 and the 3. And then I can divide by 2, but I can't divide anything there. So my 2 are 4 and -3/2. So since it's less than, open circle. -3/2 is -1.5, which is right there, open circle. Now, what we have to do is we have to decide, is it going to be in the center or is it going to be away? So it's either going to be an and or it's going to be an or. If I change this to y, one sec. So I change that to a y, and then I switch directions. Now, I know it's going to make a U. It's dashed because of that. It's shading up. So if you see, because it's greater than, it's shading up. So that means it's all here. Well, look at that. Where is it shading? It's shading in the middle. Therefore, it's -3/2 is less than x, which is less than 4. Now, what if I had the same problem, because I think this is difficult, but this time, instead of it saying x minus 4, 2x plus 3, like this. Oops, let me zoom out a little bit. How would it be different? Change that to a y. Switch the spots. Graph it there. 4, -3/2, open, open. I go like this. But I know it's supposed to be dashed, sorry. But this time, instead of shading up, I would be shading down. So that means I'm shading here. So if you look, this time, it's over here. X is greater than 4. This time it's over here. X is less than -3/2. That would be an OR. Okay? I'm going to go over the rest of the homework in the next video.